Imagine a place so extreme that physics basically waves a white flag. Place where even light can't escape. Yeah, the fastest thing in the universe. No, this isn't your Monday morning. This is a black hole. Gravity, space, and time all gang up and go. Nope, you're staying. Black holes sound modern, but the idea goes way back. In the 18th century, some scientists were already asking, what if a star's gravity was so strong that even light couldn't escape? Basically, a cosmic trapdoor. Jump to 1915. Einstein shows gravity bends space and time. Suddenly, black holes go from weird idea to, yep, possible. Then the 1960s hit. Astronomers spot Cygnus X1, where a star orbits nothing, except that nothing is super heavy. First solid black hole candidate. And the big finale, 2019. The first real image of a black hole in galaxy M87. That fuzzy orange donut? Not breakfast. Just the universe photobombing us with its most terrifying flex. Okay, we know black holes exist, but how do you actually make one? Every black hole starts with a star. Not just any star, a monster star, way bigger than our sun. For millions of years it burns hydrogen fuel like a cosmic furnace, holding itself up against gravity in perfect balance. But all good things end. When the star runs out of fuel, gravity wins. The core collapses, sometimes the outer layers explode in a supernova, and if the star is massive enough, the leftover core compresses into a black hole. It's like the star threw one last explosive party and then slammed the door. Thanks for coming. By the way, I'm a bottomless pit now. Sometimes though, the star isn't big enough to make a black hole. Then it becomes a neutron star, a super dense star with its own crazy properties. But we're here for the monsters. And once these monsters are born, they don't just sit there. They throw cosmic parties. Matter falling in forms a glowing accretion disk, spinning faster and hotter as it approaches the edge. This disk can shine brighter than a galaxy of stars, making a black hole one of the universe's weirdest neon signs. And here's where it gets really wild. Some black holes don't just swallow stuff, they shoot it back out in the form of relativistic jets. Picture this. A narrow beam of particles moving at nearly the speed of light, blasting thousands of light years into space like a cosmic super laser. These jets are powered by the black hole's spin and magnetic fields, basically turning the black hole into the ultimate particle accelerator. If you got too close, imagine standing in front of a fire hose. But now imagine its superheated plasma and charged particles screaming at nearly light speed. Yeah, don't stick your head in there. These jets can punch through entire galaxies and even influence star formation far away. Cosmic chaos served at maximum volume. Plus, as matter whirls around, it heats up and emits X-rays. That's how astronomers know a black hole is nearby, even if it's invisible. Think of it as the black hole leaving neon breadcrumbs across the universe. Yep, I'm here, and I'm hungry. But black holes aren't just cosmic bullies. They also play a crucial role in keeping galaxies in check. Supermassive black holes sit at the centers of galaxies, including our own Milky Way, holding everything together like invisible anchors, making sure stars don't drift away into the void. Basically, they're the ultimate cosmic babysitters. Silent, invisible, and terrifyingly effective. Here she comes, our babysitter Sagittarius, a star. She tells you, hide, run, grab a snack now. The ad wants to get you. It's clear you don't need to hide anymore. Eat your snack in peace. Now let's get up close and personal with the black hole itself. A black hole isn't a cosmic vacuum cleaner, sucking up everything in sight. It's a place where gravity is so intense that not even light can escape. The edge is called the event horizon, the ultimate no exit sign. Cross it and you're gone. That's the cosmic point of no return. Inside lies the singularity, a point of infinite density. Not because infinity is real, but because our equations panic and spit out infinity. Here, the laws of physics as we know them break down. It's basically the universe's way of saying, good luck, nerds. And just in case you thought black holes are boring, their gravity is so strong it literally warps space and time, bending light, stretching distances, and even slowing time near the edge. You thought relativity was weird in textbooks? Try living it. So, you've decided to be adventurous or maybe just reckless and jump into a black hole. What happens next? From the outside, you appear to slow down, freeze, and fade at the event horizon. Friends watching would see you stuck there forever, basically the ultimate slow-mo selfie. From your perspective though, you keep falling. And then, spaghettification. The part closest to the singularity is stretched first, pulling the rest of you along. Your body stretches piece by piece until you're one ridiculously long cosmic noodle. Congratulations, you've achieved ultimate noodle state. So yes, black holes are the universe's supreme pasta makers, but they've also got a surprisingly subtle side. Even these cosmic monsters have a secret diet called Hawking radiation. Here's how it works. Space isn't empty, it's bubbling with tiny particles popping in and out of existence. Near a black hole, sometimes one particle falls in and the other escapes. That little rebel sneaks away, stealing a tiny bit of the black hole's energy, effectively shaving off a bit of its mass. Over trillions of years, even a supermassive black hole would slowly shrink. In other words, black holes are sneaky dieters, shedding a little mass here and there, one quantum snack at a time. Truly the slowest weight loss program in the universe. So, you think you know black holes now? Well, almost. But here's the question. Where's the nearest one? Meet Gaia BH1, only about 1,560 light years away in our galactic backyard. It's a stellar black hole around 10 times the mass of the sun, but only city-sized in diameter. That's not impressive? Remember those two black holes we met earlier? They're supermassive black holes, basically a leveled up stellar black holes. Sagittarius A star packs 4 million suns into a space smaller than Mercury's orbit and chills 26,000 light years away. M87's black hole? 6.5 billion suns, bigger than our entire solar system, hanging out 55 million light years away. Bet your brain just did a backflip. But hold on, curious about the absolute champ? Meet TON 618, an ultra-massive black hole, the boss among stellar and supermassive black holes. It weighs a staggering 66 billion suns, big enough to span the inner part of the Milky Way, and lurks 10.8 billion light years away. Mind officially blown? Good. That's the scale of cosmic chaos. But don't panic, your snacks are safe, at least for now. So next time you peek at the night sky, remember that black holes are out there, eating everything in their reach. Go ahead, toss your worries, the mess in your room, or your homework straight into the cosmic glutton. Up next, brace yourself for more surprises that will make your eyebrows dance. Go on, click it. Free your mind for a second until we collide at the singularity again.